Hey everybody, this is going to be a follow-up to the part 1 home internet getting started video. So I'm going to go into some more advanced things that you can do once you've kind of gotten this initial setup. So I know we talked about kind of the pathway of how the internet goes to your ISP, then to your modem, and then to your router, and how normally it's nice to have pfSense as your router right here because it's also a very powerful firewall, and because it's open source you can do a lot of customization. And then from there you have your private network, and this is where this is where your Wi-Fi will be, and any IoT devices, anything like that. So we talked a little bit about DHCP, how DHCP is the service that gives out IP addresses. Um, and you're gonna be using this in your home network. So the whatever router, either your pfSense gateway or your OpenWRT router, whichever one is set up as the main DHCP server, is gonna be the one giving out or assigning these private addresses. We're gonna talk about another service now called DNS. DNS, or domain name service, is it's going to be the service that matches. So let's say you type in like, google.com in your browser. So when that happens, um, you're actually you're querying the domain name server to match up google.com with an IP address. So this domain name service is actually extremely important. This is the DNS is the middleman between all of your browsing. So anytime you're looking up any website, it's going to have to be queried by the DNS server. So there's a couple different things. DNS can be thought of similar to DHCP in the sense that if DHCP is turned off at this router level, then DHCP is going to have to take place at the gateway level instead. And DNS is the same way. If you don't have DNS turned on at your router, and you don't have any kind of like let's say, so Google's DNS server is 8.8.8. So if you go into your router and you set one of the interfaces to have a DNS server of 8.8.8, your router is actually, it's going to go out and it's going to go past your gateway, and it's going to go contact the DNS server out in the World Wide Web. And if it's 8.8.8.8.8, it's going to be Google's DNS server. So we'll have this can be DNS server. So similar to DHCP, you have a lot of options here. So your pfSense gateway by default will have a server called, or a service called Unbound, and Unbound can act as your DHCP server, or a DNS server, my bad. So Unbound DNS is going to be part of pfSense. So let's say your pfSense interface for your LAN is 192.168.1.1. You can actually set your router to have the same DNS server. So let's say let's make a Wi-Fi interface, and this Wi-Fi interface is going to have a DNS server of 192.168.1.1. So now all of the queries coming from these devices, so let's say your smartphone is connected to your Wi-Fi network, every query that your smartphone makes, assuming it's going through the Wi-Fi, is going to come from the Unbound DNS server. And so the Unbound DNS server is going to be a service on pfSense, but there's actually there's even more you can do. So just like we saw Google's was 8.8.8. Personally, I am not the biggest fan of Google. And when you use by default, your service is gonna be queried at this level. So it's actually, I'll visualize this a little bit better. It's gonna come out your ISP, and you can kind of think of it as being exposed to the internet, but it's not really. It's really going to it's just going to a DNS server. But we can actually prevent, if we don't want a request going to Google and we don't want all of our information being cataloged, we can actually set our DNS server to 9.9.9.9, and this is called, they're called Quad 9, and this is a DNS service that's anonymous and resilient, and it's also going to be actively probing for malicious sites or malicious requests. So that's an option that you can do, and there's more options that we can do as well. So if we wanted to say, see if we can find a house icon real quick. So let's say we have, maybe we're staying at an Airbnb or a hotel, and we're using their Wi-Fi instead. So they have their own home network, very similar to this, but we don't necessarily want to use we don't want to go through their system. Or if we do want to go through their system, we want it to be in a way that it's kept secret. Okay, I'm having issues with this. So basically what we can do is we can create a VPN. So let's say you have you're using your computer and you're like, hey, I don't want, because this home network is going to have all of the same stuff. It's going to have to pass through, it's going to have to pass through the Airbnb's ISP. It's going to go through their modem. It's going to use their DNS server, whichever they have selected, and then it's also going through, their gateway, their firewall, all of that stuff. But what you can do is you can actually create VPNs. So a VPN is a virtual private network. You're probably pretty familiar with them due to all of the ads and all of the hype and stuff. But you can actually really easily create a VPN onto your home network if you're using pfSense. So what this allows us to do is, you're at this Airbnb, and maybe you want to be able to log into your pfSense from home or something, or you want to not have to worry about having all of these different things, gaining access to whatever you're doing. So you would make, there's a lot of options for VPN. I think WireGuard is probably the easiest to make. As with most things, there's going to be trade-offs for all the VPN services. The main trade-off with WireGuard is, if you have WireGuard, is going to be just point to point. So like, let's say you want to connect to another server or another gateway, you're going to have to set up an entirely new tunnel just for that one connection. So like, let's say I'm using Proton VPN. All I have to do on Proton VPN to go anywhere, I have let's say 400 servers across, you know, all countries. I don't know. A lot of these VPN companies, they have, they have servers everywhere. All you have to do is just click a button and it just connects you to one of these servers. But for WireGuard, you're going to have to actually create a new WireGuard peer. So WireGuard uses, you're going to have a tunnel interface, and then for that tunnel interface, you're going to make a peer. So this computer is going to be a peer, and if you wanted to make another tunnel interface, or you wanted to use, another computer, you'd have to make a new peer. And I feel like I'm not explaining this very well, and I'm honestly not really sure how to visualize it properly. But basically, you only have the weakness of WireGuard, just traditional WireGuard, is that it's just point to point for a connection. So if you wanted to use the same peer and tunnel to connect to this circle instead, you would actually have to make a new certificate chain. You wouldn't be able to do that. You'd have to do something like this instead. So you basically you have all of these different chains of certificates for each connection that you make. And there are enterprise solutions to this, but you won't need to worry about them if you're just a single user trying to maybe make a few connections for their, like, let's say, their computer and their phone. So you have two peers for your WireGuard tunnel. You have your computer and your phone, and that's it. And that's not going to be a problem. But you would configure this on pfSense, and I can make a video showing how to do that. But the reason having a remote VPN is super advantageous is a few things. So I know in the last video we talked a little bit about IoT devices and how if you did want to have IoT devices that weren't, Amazon Alexa or some kind of Google Home device that listens to every single word you said, if you wanted to have something else and have these devices, not accessible by big tech and all of the other good stuff, there is a solution. You can use something called Home Assistant. So Home Assistant is, again, it's an open source software. Home Assistant can run on most x86 based computers. So if you had you could run this on a server. You could run this on a virtual machine. You could run this on a Raspberry Pi. I'm running one on a Raspberry Pi. Let's see. I guess we can just use like a little. So just pretend that this is a little Raspberry Pi. And so what I have is I have a bunch of, let's say, I have a bunch of light bulbs. And I have a ton of light bulbs. Maybe I have some security cameras, and I have all of these connected to a new network. And this is going to be my IoT network. So let's say I have an IoT network within my home network, and I don't want these IoT devices to have access to the rest of my network. And I have some videos configuring OpenWrt on how to make VLANs, but we can take it a little bit further. So let's say you have this IoT network and you're using Home Assistant. So what Home Assistant allows us to do is while you're setting up these IoT devices are constantly going to be querying the network. And even if you do have a configuration like the ones created in my VLAN video, if that VLAN still has access to the internet, these devices are still going to be able to, do what they do. They're going to be blasting all over your network. They're going to be, they do a lot of stuff. And if you have a pfSense firewall, what you can actually do is if you assign these devices to a VLAN, you can actually go into the firewall logs and you can see how many times each one of these devices is going to be sending out information and looking for more connections. And it's quite absurd because, obviously you're not going to be turning your lights on like 30 times a second, but then you look at your network and you just see them constantly talking. And with the light bulbs, it's not so scary, but with the cameras and with the microphones, it's kind of like, okay, well, why is this device constantly reaching out to places all over the internet? Like it's a little worrying. But what you can actually do is, so let's say you don't want these to have access to the internet anymore, but you still want to be able to control them through the internet. So with Home Assistant, you can actually do that. So we have this home network that all of these networks are a part of, and let's say we have this sub IoT network that's part of our home network, but it's completely isolated. And what we can do is we can integrate all of our IoT devices into Home Assistant, and then we can make another network. And what this lets us do is, so we have this IoT network, and in our firewall rules, we can give Home Assistant access to our IoT network. And then we can prevent our IoT network from accessing the internet. So I will give you an example of what this looks like. So let's see. So if we go to our firewall, and this is just an example of some rules. So under firewall rules, we're using the IoT interface right now. And as you can see, the source, we have IPv4, any source, any port, as long as it's going to Home Assistant. And on pfSense, you have a deny by default. So if this is our only rule, the only rule that we have is that our IoT VLAN is going to take commands from Home Assistant. That's basically what this says. If it's not coming from homeassistant.net, or it's not going to homeassistant.net, it's not viable. So these devices, these IoT devices, if they're not going to homeassistant.net, they can't get out. And this is really good because basically none of these IoT devices are going to want to talk to Home Assistant. They want to go talk to something on the internet, but they can't. All they can do is talk to Home Assistant. So, and I guess I can show you an example of. So this is an example of some Home Assistant, and some of these are offline just because I have the actual physical switch turned off. But like, let's say, and these are all on the IoT network. I want to turn off like this ceiling or this ceiling. So that one turned on. I'm turning on lights and I can turn them off. And these devices are smart, but they're not connected to the internet. They don't have access to the internet. But what's nice is if I have this WireGuard peer set up and I activate my WireGuard VPN, I can actually access all of this stuff on Home Assistant provided I have the right firewall rules set up, I will actually be able to control my devices that don't have connection to the internet. Technically, they're isolated in their own network. They can't get out, but I can use Home Assistant as a proxy to interact with them. And I can do that if I have my if I give my WireGuard interface, let's just call this Home Assistant network. If I have my Home Assistant network and I have my IoT network, you can basically, it's another way of helping you prevent data leaks or information from getting out. It's a way to securely manage these devices without using like their proprietary things. So again, this is similar to the other video in the sense that, like, yes, you can do this. Like, if you don't want Google, like, literally being able to see anything that you do, and Home Assistant actually works with Google devices, and you want to just manage your Google devices through a Home Assistant integration, you can do that. But in order to do that, you're going to have to set up a WireGuard on your pfSense, and then you're also going to have to configure WireGuard on your peers for remote use. It is possible though, and I would say it's not the hardest thing in the world, but there's definitely going to be troubleshooting involved. And I guess we can talk about IPS and IDS too. So another thing that you can do. So we have DNS, we have VPN, we have DHCP. We can also, there is a service called IPS/IDS, and IPS stands for Intrusion Prevention System, and IDS stands for Intrusion Detection System. And it's very easy to install these onto pfSense because it's like a package. You just download it. If your pfSense is connected to the internet, you just go into Package Manager and you can download an IPS or an IDS. There's a couple. I think Snort is probably going to be one of the easier ones to set up. So what you can do is you can get the Snort package on pfSense. And what this is going to do is, an intrusion prevention system, the main difference between IPS and IDS, an intrusion prevention system is going to have a set of rules. It's kind of like a firewall, but a firewall is absolute. An intrusion prevention system is not as absolute. It's going to be looking at combinations of different actions and deciding whether or not they are a threat. And an intrusion prevention system, if it decides something is a threat, it's going to block it. That's why it's called the prevention system. With the intrusion detection system, if the set of rules triggers, like a response and it's like, okay, this is a threat, the intrusion detection system will not block the threat. It's just going to let you know that something is out there. You're going to have to block it yourself. So an IDS is nice because it's not going to be, because you will get false positives with these. They're not perfect. It's just another thing to help you secure your network. But again, you will get some false positives, and a false positive might be like, okay, I have some weird thing, I'm connecting to, I don't know, I'm trying to watch HBO Max on my smart TV or something. And, it might block it. It probably won't, but it might. And if it does block it, it's not blocking it because it's like, hey, I hate HBO Max. It's blocking it because it thinks that, like, it actually thinks that it's a genuine threat, and it met some of the characteristics of one of the packages it's supposed to block. So that's why an IDS might be nicer starting out, just because you're not gonna have this package, accidentally, causing a denial of service attack, but also it's not going to be blocking anything that it thinks is malicious. And I would say as long as you set if you do want to use an IPS to, actually actively block things, that's totally fine. But there's a couple things that will happen if you use an IDS or an IPS. So first thing, you have to think about it like you have 1 gigabit per second internet connection. That's a lot of data. And depending on the machine you're running this on, if you use an IDS or an IPS, it's going to be looking at every single packet that comes through. And there's two modes. You can either choose to basically what will happen is your information, it'll come in to your network, and it'll come in without being stopped. But what's going to happen is, so like let's say your computer is not very fast and you don't want it to actively block things immediately. What these packages can do is you can actually set this package up to inspect or create a cache. So let's say you don't want it to inspect inline because you want speed over like instant blocking. So as the data is going from your wide area network or your ISP into your home network, what this snort package is going to do is it's going to take data from the stream, and it's going to create a copy, and the copy is going to go in this cache, and then it'll be inspected in the cache. But as you can imagine, like if something bad comes in and it hits the cache and then it goes in, it's going to go in. Like this cache is not going to be inspected before it goes in. But the inspection process is not going to slow down your internet the way that it would for instance, if you didn't have this stream, going to the cache. Instead, what you can do is you could do an inline inspection, but an inline inspection would look like this. So your data comes in, it gets inspected, and then it goes out. But as you can imagine, it will slow down your network speed. Like an increase of security, but it will slow down your network speed. So the cache option is nice because now you have the speed, but you also have the security because it's being looked at through the cache. But there's also there is the trade-off that if something does get in, it will get blocked once it gets in, but like that's not ideal. So honestly, there's a lot to think about. Um, there are other alternatives to Snort, um, and there's a few of them. For instance, if you are not using pfSense, I believe UniFi has I think they have a hardware appliance that's capable of being an IPS, but I would just recommend Snort because basically what Snort does is it takes a list of your choosing. There's a couple community lists out there that you can use for free, and Snort's going to take that list, which is it's going to be updated very frequently. So this list is going to be a blacklist, or it's going to be kind of like an up-to-date malware list. So like based on threat intelligence, you have a blacklist, and that blacklist is going to be loaded into your Snort package, and then you're going to have up-to-date blocking of connections. So that's why Snort's really cool. I don't know if you guys know this, but basically we used to think of antivirus as kind of like the premier defense, but all antivirus does is it scans for known threats based on whichever version you're running. So let's say you have an antivirus and it was updated in let's say January of this year. So based on hash values of malicious files, so I don't know if you're familiar with hash, but hash is just basically it's a file's contents put into an algorithm to produce something that's basically like the token for the file. So like let's say you could think of it kind of like a social security number for a human being. But the only difference is once this human being has any part of them changed, their social security number is also going to change because like let's say you have a file that says, like hi, my name is like X. That's going to produce one kind of hash, right? But if anything, literally anything in this file changes, if you delete a space right here, hi, my name is X, this has a different hash now. So let's say in January, right, you got your January update and you have this file and it's called hi, my name is X. And this file is marked under the malicious files. So you got your update in January, you think you're good, right? But it turns out the creator of this virus actually deleted one space, and now it's not covered by your antivirus anymore, and it gets through because the hash value is different. That's kind of why like antivirus, it's good, you should have it, but do not rely on it. It is not foolproof, and in fact, it is very easy to get through it. So that's why having an additional thing like Snort is really nice because it's going to have an up-to-date list. And like while Windows Defender, you can update it pretty frequently, it's not going to be, again, it's not going to be foolproof. You should have multiple layers. And there are other ways, there are other things that you can do to kind of like increase these layers. Like you have Snort, you have antivirus, you have all these block lists, you have all these segmented networks, they're all password protected. Only some networks have access to some things. And all of this stuff is good, but it's all about layers and multiple defenses, because if one of these fails, like there's a chance that the other one might catch it. If another one fails, there's a chance another one might catch it. And I think I've covered a lot in this video, so this is going to be kind of like the more advanced. I don't have any videos showing how to configure WireGuard or Snort, but I can get those up because I do think it's pretty easy to do, and it's definitely, like you're gonna get a lot of dividends back from it. So I'm gonna stop the video here, and this has been part 2 of, I guess, things to consider when creating a home network. Thanks for watching.